In this question here, we have a rectangular lot, and we're going to put a fence around it, but it's going to be split into 3 lots by 2 other fences parallel to one of the sides. So if I draw a picture of that, it's going to kind of look like that. So I have a width, a width, a width, another width, an entire length, and a length. Now I want to find the dimensions of the lot that result in a maximum area if I have 660 meters of fencing. So the 660 meters is the isolating equation because I have an answer. So I'm going to take the perimeter of this field, 660, and to figure out the perimeter, I'm going to have a width, a length, a width, a length, another width, and another width. So altogether, let's add those all up, plus the extra width to separate it. That will equal 660. So altogether, that is 4 widths plus 2 lengths equals to 660. So let's divide everything by 2, just to simplify it, and get my L so that it only has a coefficient of 1. So 4 divided by 2 is 2 W's, plus 2 divided by 2 cancels, equals to 660 divided by 2 is 330. So this is my isolating equation because I'm going to isolate for one of the variables. So it looks like the easiest one to get by itself is the length. So I now know that my length is 330 minus 2W. So now that I've isolated it, let's go to the substituting equation. I want a max area, and area is length times width. So my maximum area, I can't have 2 variables. I'm going to use my new expression for length, is going to be 330 minus 2W times W. So applying the distributive property, I get that my max area is 330W minus 2W squared. And that's the equation that I'm going to complete the square for. So what I'm going to do, write it out like this, is divide everything by the leading coefficient of negative 2. So negative 2W squared divided by negative 2 is W squared, minus 330W divided by negative 2 is negative 165W. So up to my grid to complete the square. I take my W squared here. I'll take my negative 165W and split it into 2 equal pieces. So that's 82.5W, negative 82.5W. And let's look at how that factors. So here, GCF of W, here, GCF of W. I'm going to take out my leading coefficient here and my leading coefficient here. So I always like to just stop and check to see if I did that correctly. There we go. So W times W, W squared. Negative 82.5 times W is negative 82.5W. W times negative 82.5, negative 82.5W. So to find out what completes the square, I multiply negative 82.5 by negative 82.5, and I get 6,806.25. So that's what's going to complete our square. I'm just going to move this over so I have a little bit more room. There we are. And inside the brackets, I'm going to add 6,806.25, and I will also subtract 6,806.25. Now the reason I add and subtract is because 6,806.25 take away 6,806.25 is just 0. And I can add 0 to any equation. So completing the square, I know that factors as W minus 82.5 times W minus 82.5, or W minus 82.5 squared. That's my perfect square trinomial. But I'm going to take negative 2 times 6,806.25 outside the brackets, which is 13,612.5. So looking at this, my vertex is opposite of the inside and straight up on the outside. And because it's negative, I know that my parabola opens down, so I do in fact have a max. So in terms of my vertex, this tells me what my max or min is. This tells me when my max or min occurs. So what my max is the maximum area. So my maximum area is going to be 13,612.5 meters squared. And when it occurs, see how we have a W? It occurs when the width is 82.5 meters. Now let's go back up here and figure out what the length is. So the length is going to equal to 330 take away 2 times 82.5. So I'm going to take 82.5 multiplied by 2 is 165. So my length will be 330 take away 165, which is of course 165. So my length will also be 165 meters. So let's look at this all together now. Make sure I answered the question. It said find the dimensions, there they are, that result in a maximum area, this is my maximum area, with 660 meters of fencing available.